Today's lesson will be on mean absolute deviation. The mean, we know, is the average of the data, so you add up all the numbers and divide it by the number of numbers there are. Absolute is like absolute value, so it's the positive version of a number, or the distance from zero in terms of absolute value. And deviation is how much the numbers vary, or how much they deviate, how much they change. So the mean absolute deviation is the average distance from the mean. And it describes the variability of the data, or how spread out the numbers are. The first thing we have to do is find the mean, median, and range for each of the sets of data, just so that we can really understand what mean absolute deviation is. So the mean, we know, is when we add up all the numbers and divide by the number of numbers. So you can see that I wrote that they add up to 560, and when I divide by 7, because there's 7 data points, I get 80. Then we know that the median is the middle number, or 80, and the range is 40, because you could do 100 minus 60. This is true for both data sets. They're both given to us in order already. The maximum number is 100, and the minimum number is 60, so the range is 40. The median, or the middle number, is already given because we have an odd number of data points, so 80 is our median for both. So looking at these two data sets, I notice that both my means are the same, my medians are the same, and my range is the same. But I want to look at how they're different. If you look at set A, the numbers, I have 60 and 61, which are very close together, 65, which is still pretty low, then 80 in the dead center of those two minimum and maximum, 95, which is pretty high, and 99, which is almost our maximum. So they're very close to the minimum and maximum. If we look at set B, we notice that the numbers are clustered around the 80. So we have our minimum and maximum, but then we have 1 less and 2 less, and then 1 more and 2 more than our median number. So even though we have the same mean, median, and range, these are very different sets of data. We want to know how we can compare this data, so we're going to use mean absolute deviation, which is the average distance from the mean. The first step is to find the mean. The second step is to find the distance of each value from the mean. And the third step is to find the mean of the distances. That should say the, but I can't really go back and change it. So I want to look at my data points. Notice that I have 7 data points that I wrote below, and now I want to find how far away each of these data points are from the mean. Since our mean is 80, I know that 60 is 20 away from 80, 61 is 19 away from 80, etc. Notice that I filled in each of the distances from the mean, and I'm always using the positive distance. So now I've found the mean and the absolute distance, or positive distance, of each value from the mean. Now it's time to find the mean of those distances. So if I add up those 7 distances and divide by 7, I get 15.43. That's my mean absolute deviation. Now you might be wondering what this means. Let's compare it to this mean absolute deviation for our second set. You can try it on your own, or you can follow along with me. So again, I'm going to write my data set, which is my 7 numbers from set B, and find each of the distances from the mean. So in this case, 60 is 20 away, 78 is 2 away, 79 is 1 away, etc. And now I've found the mean. I've done step 2, so I found the positive distance between the mean and each of these data points. And now I need to add up all those distances and divide by the number of numbers there are, because I'm finding the mean of the distances. When I do that, I get 6.57. So for our first set, we had 15.43, and for this set, we had 6.57. So what that's saying is that the average distance away from our mean is much smaller for this one. So our data points are much closer together. Whereas if we have a bigger mean absolute deviation, then the average distance from their mean is bigger. So the data points are farther away on average from our mean. You might be wondering when this is important, but we often look at deviation, particularly in high school you might use standard deviation, which is a lot more common. But either way, we're looking at how spread out the data is. Especially as a teacher, I may look, and two classes might both have an average of 90%, but if one class has a lot of hundreds and then a lot of 50s, that's a lot different than if there were a lot of B's and a lot of low A's. Now you try. Flip over your paper and find the mean, median, range, mode, and mean absolute deviation for the given line plot. Notice that there's x's above certain numbers. For example, there's 2 x's above the 4, 1 x above the 5, 2 x's above the 6, and these are shoe sizes of 7th grade students. So what I started doing at the bottom is I started writing out my data set. Since there's 2 x's above the 4s, I know that means that there's 2 4s. There's 1 x above the 5, so that means that one student has a shoe size of 5. There's 2 x's above the 6, so I know that 2 students have a shoe size of 6. So by writing out each of my points at the bottom, it will make it easier for me to visually find the median by finding the middle number, and it's easier for me to use the data. If you prefer to use it straight from the line plot, that's fine as well. Don't forget that the mean is the average, or you add up all the numbers and divide by the number of numbers there are. And the mean absolute deviation, after we've found the mean, we need to find how far away each of the other numbers are from our mean by using subtraction, and then we find the average of those distances.